Let's dive right into this explainer. We're going to cover exactly what you need to know about Replication Factor 1, or RF1 for your Nutanix certification. Specifically, we're locking in on the NCP-MCI 7.5 exam, section 4.4, which is all about RF1 caveats. Look, if you're an infrastructure admin gearing up for this test, you already know Nutanix is absolutely famous for its rock-solid data resiliency. But RF1, well, it flips that entire paradigm completely upside down. Today, we're going to unpack exactly what happens when you strip away those safety nets, how the Acropolis operating system, or AOS, handles it, and, most importantly, exactly how the exam writers are going to test you on it.
So to make sure you're totally prepared, our agenda is pretty straightforward. First, we'll look at why RF1 matters, then a detailed walkthrough. Next, we'll hit some common exam traps, and finally, the key facts you absolutely need to memorize. Part 1. Why RF1 matters, or as I like to call it, operating without a safety net. Seriously, using RF1 is kind of like walking a high-speed tightrope, and there is absolutely no safety net below you. By definition, Replication Factor 1 means exactly what it sounds like, right? One single copy of the data, zero redundancy, and literally no guarantees of data availability if your hardware decides to fail. Now, in a standard Nutanix cluster, you're usually cruising at replication factor 2 or 3. AOS is working behind the scenes, making sure that if a node or a disk just dies, your data is perfectly safe and accessible somewhere else. But with RF1, you are explicitly telling the cluster, hey, do not make copies. All the data in an RF1-enabled storage container is permanently tied to one specific node that you choose. Now, you might be wondering, why would any sane infrastructure admin intentionally choose zero redundancy? Well, it all comes down to pure I/O performance. By not writing copies of data across the network to other nodes, you completely eliminate replication latency. It's a real game changer for write-intensive applications that simply don't need storage-level data protection. We're talking about heavy-duty workloads, artificial intelligence, machine learning, big data, or apps that actually handle their own high availability right at the software layer. You get blinding speed for ephemeral data, for sure, but you are completely trading away the underlying safety mechanisms we usually rely on. I need this number permanently burned into your memory for the exam. 0. 0 represents the amount of data redundancy you get. It's the amount of recycle bin retention time you get, and it represents the exact number of backup copies available if a drive fails. When you see RF1 on that test screen, your brain needs to immediately scream zero safety net. All right, moving on to part 2, a detailed walkthrough of RF1 in the real world. Let's see how this translates into some real-world administrative nightmare scenarios if you aren't ready for it. You might be wondering, what actually happens when a failure occurs on an RF1 storage container? How does AOS handle a sudden disk or virtual machine or VM failure under these super strict conditions? Normally, as we know, the cluster just self-heals. But with RF1, those standard operating procedures, they are completely bypassed. This contrast really hits the nail on the head. Think about it. A standard RF2 or RF3 container protects you. It optimizes storage using data duplication, and it guards against human error with a 24-hour recycle bin retention policy for deleted VMs or volume group vdisks. An RF1 container, on the other hand, aggressively strips all of those features away. There's no deduplication, and it bypasses the recycle bin entirely. Let's walk through exactly how this plays out during an actual hardware failure. Okay, here's our first concrete example. Step 1, a physical disk suddenly fails on the specific node where your RF1 container lives. Step 2, AOS does what it's programmed to do, right? It looks around for a replica on other disks or nodes to kick off a rebuild. But in step 3, because this is RF1, it finds exactly 0 replicas. So step 4, the data just cannot be rebuilt. Actually, it gets worse. According to the official documentation, if you try to logically remove that failed disk, the disk removal process might literally get stuck because the system is trying to handle data that has no extra replicas. You physically have to go in and manually delete the RF1 data on that degraded disk just to unblock the disk removal process. Crazy, right? So the absolute crucial point here is exactly what the documentation states. For a failed disk with RF1 data that has no extra replicas, the data cannot be rebuilt. You simply cannot rebuild what doesn't exist. That single hardware loss has just instantly become a permanent data loss. Now, if that data was just your ephemeral machine learning processing data, hey, no sweat, you just spin it up again. But if it was anything critical, it is gone forever. For our second example, let's talk about good old human error. Imagine an admin accidentally deletes a guest VM or a volume group vdisk on a standard cluster.
Normally, you've got that nice 24-hour grace period where the recycle bin holds onto those files, assuming you haven't hit critical storage thresholds, of course. But if that VM happened to be on an RF1 container, AOS actively skips that 24-hour recycle bin check. Those vdisks are marked for immediate deletion. There's no undo button here, folks. I really want to highlight this direct note straight from the source documentation. It explicitly confirms that when Replication Factor 1 is enabled for a storage container, the recycle bin is hard disabled for that container, 0 exceptions. The entity is marked for deletion as soon as possible. And trust me, the exam is absolutely going to try to test your knowledge on this specific behavior. All right, part 3. Let's navigate some tricky wording with these common exam traps. Look, the test writers know exactly how to trick you into assuming standard cluster rules apply to RF1. They're going to throw scenarios at you that sound perfectly reasonable for an RF2 cluster, but are fatal mistakes for an RF1 setup. Here are the 3 most common traps you're going to see. Trap 1. They'll give you a scenario about optimizing storage on an RF1 container and offer deduplication as the answer. Trap 2. They'll present a story where a junior admin accidentally deletes a VM on an RF1 container, and they'll ask how long you have to recover it from the recycle bin. And Trap 3. They'll ask you for the specific steps to upgrade or increase the replication factor of an existing RF1 container to RF2. Remember, every single one of these actions is literally impossible. Please do not fall for it. This is a massive caveat. While data compression is actually supported on RF1, deduplication is completely and strictly unsupported. You cannot do it. Furthermore, you can't just change your mind later. The documentation clearly states that increasing the replication factor of an RF1 container is unsupported. You can't just flip a switch down the road and make it RF2. Oh, and you can't enable capacity reservation on it either. You also really need to watch out for these hypervisor and deployment edge cases. First, RF1 is totally banned, not supported for clusters running Microsoft Hyper-V. Second, for mixed clusters, it's also banned for Acropolis Hypervisor or AHV, storage-only nodes in a mixed VMware ESXi and AHV cluster. And third, this is probably the most important one for your architecture questions, you absolutely cannot deploy Prism Central on an RF1-enabled storage container. The system just relies on Prism Central way too heavily to risk putting it on a container with 0 fault tolerance. And finally, part 4, the key facts to memorize for our final review. Okay, let's lock in the essential facts you absolutely must memorize before you walk into that testing center. Honestly, if you understand the logic we've discussed so far, these are going to be second nature to you. Here is your high retention summary. Fact 1. There is no duplication on RF1, though compression is totally fine. Fact 2. The recycle bin is bypassed entirely. RF1 vdisk deletions are immediate and permanent. Fact 3. No resiliency exists for RF1 data, meaning no extra copies are made, so data cannot be rebuilt if a drive fails. And Fact 4. You cannot increase the RF level of an RF1 container later. It is locked permanently. Listen, if you remember only one phrase from this entire explainer for your exam, let it be this: single loss equals data loss. You are explicitly trading every ounce of Nutanix's legendary data protection for raw, unadulterated I/O performance on a single node. So, knowing the severe limitations of this high-speed tightrope, are you ready to conquer the RF1 caveats on your NCP-MCI 7.5 exam? Remember these rules, trust your understanding of the underlying AOS mechanics, and you are going to easily spot those wrong answers on test day. Thanks so much for joining me on this explainer, and best of luck on your exam. You're going to crush it.